Here we go. So we are graphing roses and spirals today. Focus on roses. Spirals are pretty straightforward when we do these things. For each rose equation, find the maximum. This is not a tough concept. Looking at number 1, you've got 5 times sine of 2 theta. What's the biggest possible value you could get for sine of 2 theta? 1. The biggest you can get with sine is 1. And so my maximum value I can get is 5 times 1. My max is 5. My maximum is 5. Then, in addition to that, let's talk about where and how many petals it's going to be. So if I want to know, find the maximum is 5. Where is that going to happen? Well, that's going to happen when sine of 2 theta is equal to 1. That's not all of the spots. I'm only going to find one of them. If I know 1, I'll be good. So when is sine of 2 theta going to be equal to 1? So it's really answering the question, when is 2 theta going to be equal to 90 degrees? Because 90 degrees is when sine is 1. And so I have a maximum of 5 at, divide by 2, 45 degrees. I'm going to have a maximum of 5 at 45 degrees. That is when that's going to happen. How many petals is my rose going to have? Show me with your fingers. How many petals is this rose going to have? This number right here tells you how many. It's an even number. So if it's an even number, we double it. That's going to have 4 petals. Where is the maximum going to happen? And 4 petals. Again, that's not the only maximum. There's going to be 4 maximums because there's 4 petals, but we found one of them. Do the same thing for the next 2. Finding maxes. So again, my maximum value is 3 times 1, because the biggest cosine of 2 theta could ever become is 1. That's just the range of sine and cosine. So my maximum is 3. To answer when that's going to happen, we're trying to figure out when cosine of 2 theta is equal to 1. So Kate, when is cosine of 2 theta going to be equal to 1? When is cosine going to be 1? At 0 degrees. So if 2 theta is equal to 0, what is theta going to be? 0. So it's a maximum of 3 at 0 degrees. That's not all of them. That is 1 petal. Show me with your fingers, how many petals will this thing have altogether? It's an even number, so whatever this number is here, we double it. There are 4 petals. Let's look at number 3. This one's a little bit tougher. Show me with your fingers, what do you think the max is going to be? Your max is going to be 7. I want this to be 7. All right, we could talk about -7. -7 is not weird, but it gets us a little bit strange. -7 times what would we want that to be to get you 7? -1. And so I'm answering the question, when is sine of 5 theta going to be equal to -1? So I want to know when 5 theta is equal to 270, because that is when sine is going to be -1. Then I got to just take 270 and divide that thing by 5. What's theta going to be? 54 degrees. Show me with your fingers how many petals altogether? 5. 5 petals. Everybody good with that so far? Let's do it again. Let's just to make this a little bit easier to see, let's change that 2 to a 3 just to make it slightly bigger. Otherwise, your picture's a little bit small. Do the top part. What type of graph? When I say type of graph, I mean a rose and how many petals. Figure out the symmetry. Find where the maximum is going to happen. Do that right now. Number 4, we're graphing. It's a rose. Show me with your fingers, how many petals is it going to have? 4 petals. You got a 2 right there. We double it. A 4-petaled rose. Show me with your hands, how are you going to fold this graph? What type of symmetry does it have? Show me with your hands. Fold it. It is cosine. So if it's cosine, that means it has what type of symmetry? x-axis. It could have more than one, but technically this is an x-axis symmetrical graph. Here's the thing you'll notice. If it's got an even amount of petals, it's going to have a lot of symmetry. If it has an odd amount of petals, that's when the symmetry is really going to matter. So this one, it's got a lot of symmetry. Maximum. Show me with your fingers what your maximum radius going to be. Tree. Your maximum is 3 because that's the biggest number. What we are doing then is I want to know when cosine of 2 theta is equal to 1. Because if I plugged in 1 for cosine of 2 theta, that would give you your maximum of 3. We're going to solve from there. And so we are going to figure out when cosine is 1. So 2 theta is going to be equal to 0 degrees. If 2 theta is equal to 0, then theta is going to just be equal to 0. That tells me one rose petal is at 0, 3 degrees. When we graph roses, we could go through and find all the other ones. We could do what we did in bell work and solve them all. It's not fun, but we could do it. All right. Instead, we're going to do some cheat steps here. There are 4 petals. How many degrees are there in a circle? 360. Guess what? When we make roses, they are evenly spaced out. And so to figure out when all the rose petals are, we are going to take 360 degrees and divide by however many petals I have. So I take 360 degrees divided by 4 petals. That tells me that each petal is how far apart? 90 degrees apart. It's doing some basic math here. So if my first one's at 0, my next one is going to be at 90. So I'm going to have a dot here. And I'm going to add 90 again. So now I got 180. And I'm going to add 90 again. I'm going to get 270. And guess what? If I added 90 again, it would take me back to 360. So it would take me back to the start. Think about this question for a second. What would you get? Look at this equation. It was 3 cosine 2 theta. 3 cosine 2 theta. What would you get if you plugged in theta and made theta 45 degrees? Talk in your group. What would you get if you made theta 45 degrees and plugged in 45 degrees? What would your radius be? Show me with your fingers. If you plugged in 45 degrees, show me with your fingers, what would your radius be? Radius would be 0 because it would be 2 times 45, so 90 degrees. And what is cosine of 90 degrees? That would get you 0. That is why it always goes back to the center. We are general sketching this thing. I'm going to change my window here back to 360 because I want 360 degrees of graphing. But if I graph 3 cosine 2 theta, and I graph, it's slowed down so you can see it. Look how it graphs it. That is the perfect starting at 0 and going all the way around a 360 degree way of graphing this. I'm not going to be quite that precise. I'm just going to connect the dots. But technically, that's the way it's going to go. We could have plugged in 0 and then 45 and then 90 and everything else. That's not super exciting. Does that graph have x-axis symmetry? It better. We said it was cosine. So then all I'm going to do is I'm going to connect the dots. You're doing the best you can. Try to be as pretty as me, but you're trying to connect the dots through. I got to make that a lot bigger. Whoosh. Oh, yeah. Mega rose, a 4-petaled rose. Here we go. We're graphing. Garrett, what type of... it's a rose, obviously. How many petals does this guy have? 3 petals. Symmetry. Allison, what type of symmetry is this graph going to have? X-axis. It's a cosine graph. Cosine, we think X. It's X-axis symmetry. A maximum here. Audrey. Maximum of 4. And when was that going to happen? At 0. Because she wanted to know when cosine of 3 theta gets her 1. Because if it got her 1, then it would work from there. So cosine of 3 theta, that would be when is 3 theta equal to 0 degrees. And so when I divide, I get 0 degrees. So one of her petals is at 40 degrees. Then we're going to continue from there. We could do some different math. I think the easiest way of doing it is thinking you have a 360-degree circle. You're splitting up into 3 equal petals. And so how far apart is every petal going to be? 120 degrees. And so I'm going to take 0 plus 120. That would get me 120. And so I have another petal out here at 120. I do it again, and I add 120. This time it's 240. And so my other petal is here at 240. I'm always going to go back to the center. I'm going to start here. Oh, yeah, you can be jealous of my flower. There's my flower, my rose. It goes back to the center. Does it have x-axis symmetry? Yeah, it doesn't have y. The last one had both because it was an even amount of petals. When you have an odd amount of petals, the symmetry matters. Questions on this? You can always check with your calculator. Make sure it looks good, though. Here we go. Flip it to the backside. On the backside, we're doing a little bit more of an awkward rose, and it's fine. It doesn't change anything. We can do whatever. Just because it's a little bit tougher, don't be discouraged by it. Graph R equals -5 sine 5 theta. Show me fingers. How many rose petals? 5 petals. Symmetry. Show me with your hands. How are you going to fold this graph? It's sine, so it's got y-axis symmetry, so you're folding it like a book. My radius is going to be 5. That's going to be my maximum. And then this is the only place that's maybe slightly different. -5 sine 5 theta. I want this to be a maximum of 5. So you're answering the question, -5 times what gets me 5? -1. And so I'm answering the question, when is sine of 5 theta equal to -1? So 5 theta needs to be equal to 270 degrees. And so when is my first petal going to happen? At 54 degrees. I'm taking 270 and divided by 5. That is going to be when my first one happens, at 54 degrees. So I'm doing the best I can. That's 45. That's going to be 54, somewhere right about there. That's my first petal. The rest of them are going to be spaced out evenly. I just need to figure out how spaced out they're going to be. I have 360 degrees on my graph. I'm going to take each of those numbers and I'm going to divide it by 5 equal petals. So every rose petal is going to be every 72? Yeah, every 72 degrees apart. And so all I need to do is take 54 plus 72, and it gets me my next rose petal. My next rose petal is at 126 degrees. So 126 would be somewhere in this region. And then I do it again, 126. Finish that thing. My other angles were at 270 and 342 when I added 72 degrees again. If I added 72 degrees to 342, guess what? It matches back up with that original starting dot. We're starting here, and I'm connecting the dots to make my rows. Oh, this is ugly. Oh, no. All right, that was not my best one. But connect the dots, make a rose, and work from there. It's not pretty. Hey, last thing of the day is this graph, 1 over pi theta. Anybody know what 1 over pi theta is going to be? This is a spiral. It's a spiral. When we did them the other day, it was something like 2 theta. With 2 theta, it's pretty easy. But because the numbers get a little bit off, I picked easier numbers. I used 1 over pi theta. It actually makes it a lot easier. All right. So we're going to do this in radians because radians is going to be easier than degrees, just to help us out here. What type of symmetry is this spiral going to have? Is it sine or is it cosine? It's neither. There isn't any symmetry on this. It's a spiral. Spirals don't have symmetry. They're going to fold out. What's my maximum? If I'm going with theta, what's the biggest number I can make? It depends on the theta. So is there a limit as to how big my spiral can get? Draw a spiral. You just keep getting further and further from the center. It's not limited. And your angle's going to keep growing. If I limit the interval, then yeah, you're going to have a maximum amount you could have. All right, so if I said on the interval from 0, I'm just going to say one here, 0 to 5 pi. If I said the maximum theta you could use is 5 pi, what is the maximum radius you could get? If I'm saying the biggest number you're allowed to plug in is 5 pi, what's the biggest radius you could get? 5. The pi's would cancel out. So let's graph this thing. And we're doing a fairly straightforward one. Let's just start at 0 and work my way around. So at 0 degrees, at 0 radians, we are doing radians here. 1 over pi times 0. What would my radius be? 0. So I would start with a dot right here in the center. Let's go to the next dot. Let's do a radius, or let's go at pi over 2. If I plugged in pi over 2, what would my radius be? So I'm going 1 over pi times pi over 2. What would my radius be? A half. Notice why I picked 1 over pi as my coefficient. So it's a half. So there's pi over 2 up there at the top. It's a half. And so if I were to connect the dots would look something like that. It would be a little baby spiral working that way. So the next one, let's do pi. So I'm doing 1 over pi times pi. What is my radius going to be over here at pi? 1. And so now I got a dot here. I'm going to work my way out. If I only graphed from 0 to pi, that would be the whole graph. Let's keep going. Let's go to 3 pi over 2. At 3 pi over 2, what's my radius going to be? 3 halves. And so I'd be down here at 3 halves. So it's going to keep spiraling out to 3 halves. If I went to 2 pi, my radius is 2. So it's going to spiral out. So normally, that's how much I would make on my graph. Continue with that thing. Keep going till 5 pi. You don't have to write them out. You can just kind of go. Connecting dots, so it's 2, and then it'd be 2.5, and then 3, and then 3.5, and then 4, and then 4.5, and then all the way to 5. So as I continue to spiral out, oh, that got ugly. But it gives you a pretty satisfying spiral as you go. If I were to keep going, it would keep getting bigger and bigger and bigger. It's kind of fun to play around. Originally,